Hello, SL2. This optional topic is talking about sequences and series. And if you remember back from Algebra 2, there's two kinds, arithmetic and geometric. And what I'm starting off here is just to see where they are in your formula packet. And they're part of Topic 1, Algebra. And all of these formulas here are laid out and will be there for you on the SL1 and SL2 paper 1 and paper 2 exam. So just make sure you have your formula packet and see where I am, and then we're going to practice some of these problems. So starting right off, some of these terms may be a little rusty because it's been a few years, so wanted to review some of the vocabulary. And remember, we're talking about patterns here, and a list of numbers where there is a pattern is called a number sequence. And the members or numbers of that sequence, they're called terms. So just remember that what these words, vocabulary words mean. An arithmetic sequence is when you add or subtract the same fixed number to get the next number in the sequence. And then remember that number is called a common difference. A geometric sequence is when you multiply or divide by a fixed number, and remember that number is called the common ratio, or R. Also, there are sums, and they're also called series. A sum is also called a series. And notice in our vocabulary, our formulas here, our S is our series or sum. Here's our arithmetic sequence, and here's our geometric sequence. Lastly, the last vocabulary word you might see is arithmetic mean, and that would you can find a number between two other numbers by taking the average. You're just using that the knowledge of the common difference. If you're not given that, then you can take the average of the two terms on each side of it. And then also with the geometric mean, if you have the terms on either side, you can find that using ratios. So wanted to make sure you remember those vocabulary words as well. Alright, so the ones I'm going to be showing in this video today are all IB problems that you could see on the IB exam. Alright, our first one here is it tells you, which is great, it tells you it's an arithmetic sequence, and it gives you the U1 and the U3. And there's three things it wants you to find. Okay, so I just copied the formula so they're right here in front of me. And so it's gives us the U1 and the U3, and they asked us to find the D, the common difference. So I'm just going to use my first formula here. I know U3 is 8. And I know U1 is 2. That's the first term in the sequence. In this case, my n is 3 because that's what we were given. So I'm going to have 3 in for n minus 1 so that I can find my D. So we just simplify here. 3 minus 1 is 2, 2D. And then we're going to subtract 2 from both sides. And we find that D equals 3. So that's A. Now that we know the common difference, we can use that to find part B for U20. So same formula, we're going to find the 20th term now in the sequence. So my first term plus our n minus 1, so n is 20, now that's what we're finding. Our common difference is 3. And we're just going to simplify here, and so 19 times 3 plus 2. So there'll be 2 plus 57, and so that would be 59. Okay, for part C, we're finding the sum or the series here of the first 20 terms. So we're going to use the sum formula. So again, our 20 is going to be n, our u1 is still 2, and we know our d, so we're going to be plugging in. We could use this big formula to find it, or the second formula, and in this case, since we know our 20th term and our first term, then I think it'd be faster to use our second one. So it depends on what you're given, but either one at this for this part we could use. So I'm going to use the second formula. So my sum of the 20 terms would be 20 over 2 times my u1 plus my u20. So that's going to be equal to 10 times 61, which is equal to 610. Okay, so that's using all of the arithmetic sequences formulas. Let's look at another problem. And this one is asking us to find the first 3 terms of an infinite geometric sequence. Actually, they give us those terms, 32, 16, and 8. And they want us to find the value of r. Then they want us to find the 6th term, and then the sum to the infinity of the sequence. So let's look at our formulas again. So here we're going to be using our geometric sequences formulas and our infinite geometric sequence formulas. Okay, so first we need to find the value of r. And if we were looking at this pattern, the first term is 32, then 16, and then 8, we can see that we're multiplying by 1/2 each time to get each term. To show that, you can take the second term and divide by the first term, but our r in this case is going to be 1/2. It should work for each one. So we could also have taken the third term and divided by the second term. Either way, we're going to get r to be 1/2. Now we want to find the 6th term. So you could count it out if you want, and that might be the fastest here. We know the 4th term would be 4, and then the 5th term would be 2, and the 6th term would be 1. So that might be the fastest. If they ask us for the 15th term, that would not be the fastest. So if it was a higher term, we might want to use this formula. So let's just make sure we know how to use this formula. So we should get the same answer either way. So to find the u6th term, we're going to have the first term in our sequence would be 32. We know our r is 1/2, and we're finding the 6th term, so it would be 6 minus 1. So that equals 32 to the 1/2 to the 5th power. And so this 5 is going to the 1 and the 2 here. Remember our exponents. So 32 times 1 to the 5th and 2 to the 5th. And then 1 to the 5th is 1, 2 to the 5th is 32. So that has it as shows that we did do it correctly. The 6th term is 1. Okay, our last question is asking us to find the sum to infinity of this sequence. So we're going to be using our sum of an infinite geometric sequence formula, and that is the first term divided by 1 minus r, and that can only be used when r is less than 1. So again, our first term was 32, and our r is 1/2. So we would have 32 over 2 over 2 minus 1 over 2, which would be 32 over 1/2, which would be equal to 32 divided by 1/2, which means it'd be multiplied by 1/2. I multiply by 2, the reciprocal here, which would be 64 is our sum of our infinite series. Okay, let's take a look at a couple ones I want you to try on your own. There's 2 here. Go ahead and try these 2 with the formulas on your own and then bring it back. Okay, for the first problem you should find that D is 3, and for part B that N is 1,235. For the second problem you should find that R equals 1/5, and that U10, you could have written it 3 different ways. Notice all 3 ways. 1.28 times 10 to the negative 5 is one of the ways. For part 2 of B, you would have 25 times 1/5 to the n minus 1 power. And lastly, the sum of the infinite sequence would be 125 over 4, or you could have used 31.25 or rounded to 3 significant digits to 31.3. Okay, let's look at, there's also sometimes application problems. So let's look at the possible application problems that you might have. So take a look at these 2 problems and see which of the sequences and series formulas would you use. Remember, sequences is looking for terms, and then total would be looking for a sum. So, and also you have to make sure you know if it's what's the pattern. Is it arithmetic? Is it adding? Or is it geometric? Are we multiplying? So go ahead and try number 3 and number 4 and then bring it back. So here's 3 and 4. So go ahead and try those and then bring it back. So the first thing to realize with the problem number 3 here is that it's arithmetic. Each row we're adding 2 seats on. So our first row is 15 seats. Our second row is 17. So to find our difference, we 17 minus 15, which would be 2. Also, they tell us the common difference in there is 2 more seats in it than the previous row. So sometimes we can find it 2 ways. Part A wants us to find the number of seats in the 20th row. So we'll use our U of n formula. So U of 20, and that would result in 53 seats in that 20th row. Then they want us to find the total number of seats in the theater. So we're going to find the sum of all 20, and I used the second one. You could have used the first one as well. And you should get 680 seats in the theater. For number 4, this one is our compound interest rate. So, and 6.3% annual compound interest. And remember, these formulas, they'll be using geometric. And one thing to remember about them is that each increase each year is going to be 6.3%. So when you're adding on your money. So you would have 100% of your money plus an additional 6.3%. So a total of 106.3% will be the increase each year. So our multiplier is 1.063, or our R is going to be 1.063. So our original amount that was invested in our R is 1.063 to our N number of years. So take a minute to write this down if you forgot that part about compound interest. Our part B is just plugging in then 5 to our formula that we found. And part C is then setting it as an inequality. So we knew this had to be greater than 10,000 and then solving using logs.